Hey, how are you? I'm doing well. So for this session that calling Codebase coding session, I'm with Ira. That he is returning to the project after a few years, and so I'm going to walk him through um, some of the very basic aspect of the code base, so that he can get up to speed and start coding as soon as he wants. Okay, so this is from the very beginning. So if you're watching this, it might help you if you are starting here. Okay, let's do it. So you were asking me, Aira, about where to start, right? Okay, so the app we have in the same repository we have more than one app. Just to clarify, okay? You're watching my screen, right? Yeah. I am hearing some notifications on your phone or something. Yeah, because that's entering into the line. Yeah, I understand. My monitor is a little bit big, so you will see it's like small. But okay, so from the beginning, what we have is that we have more than one app. One is the platform, what we call the platform, the one I'm showing you here. This is the platform for algo traders. Okay. The second one is the network that is under development, but as of today, there is like a first iteration, so you can run the network. I'm running it right now, and that's a different application. Then you have another one that is called the desktop application, that is referring to the desktop version of the social trading apps that we are developing with different teams. There is a team working on this on the desktop. In particular, they are doing a version of the desktop with React, so they are using this desktop React. Okay, and okay, so just to have an idea. And there is another app that is the task server. Okay. These are the processes where the bots run, the trading bot, the data mining bot, and all the bots. They run at an independent Node.js process that we call task server. Okay. Okay. So where does the platform start? If you go to the command prompt and you run the platform, you will notice that we type here. You're still there, right? Because I suddenly I'm not here. Okay. So the way we run this when it is not the package version of the app is Node platform. That means Node.js platform. So platform is a script here. This one, okay? Platform. Okay, I'm going to run it with a parameter no browser. So because I already run in the browser here, okay. So I run it again with no browser and it start the Node.js process. Remember, we have the platform is two things at the same time. It's a Node.js process and it's at the same time a web application. So the Node.js process have a set of services, an event service, something related to the integration with GitHub, and uh, something to serve the files, calculated with indicators. A set of, I don't know, 10 services, let's say. And then there is a web app that runs inside the browser. Okay. So essentially the platform runs with this script. From this script, platform uh, jumps into platform root, and from platform root then jumps into here, platform app, and from here the rest of the code is either of the platform is in the folder called client. you have several of these services that I was mentioning. Okay, the platform has inside, and the UI part of the platform has these scripts here. Okay, so these scripts are going to the browser. The client scripts are the one running the platform at the Node, as a Node.js process. Okay, so that's the basic structure of the platform for algo traders. Then, once you have this clear, this small structure clear, the next thing you need to know in importance is the contents of these projects folders. Okay, yeah. Okay, the console information, this doesn't have log files. The console information goes to the console where you're running the platform, essentially. And yes, in this case, yes, because here they don't run the trading bots or the bots processing data. All that stuff, yes, they do have logs for debugging that are stored at this folder that is inside platform. You have my log files, and then you have a lot of log information, but for this kind of process, because these processes are like the business of super algos, the trading bots, the data mining bots. For the platform itself, we don't have right now independent logs. Yeah. The thing is that we didn't use this Electrum application until maybe a month ago. So for the 4 years of the project, everybody was running from in this way, the way that I'm using now, that is by cloning the repository. So there was no need to get information into files, because everything we can see at the console, or we can easily debug this in this way. Look, you come here, Visual Studio Code, and if I want to debug the platform, I open this workspace, and it opens in Visual Studio Code, and I just run it, and it runs. I'm going to put a breakpoint to show you how to stop it somewhere. But let me check here. For example, this HTTP interface. Yeah, if I have to do something here, it's much more efficient for me to use this IDE and debug line by line. I wouldn't be console logging that much unless it's something like very trivial. But otherwise, I just use this and put a breakpoint and see what is going on exactly. In the case of the platform code, yeah. Okay. Let me ask you one question. Why are you trying to use the binary, the package application? What are you trying to achieve there? Okay. Yeah, but for that you don't need the Electron application at all. To be honest, I haven't used it yet, not even once. So the only people who are using them is like new users that they are not non-technical enough in order to clone the repository to run the commands. But as a developer, I mean, uh, no, of course, and it should be working. But it's so new that probably you are entering into some path that still nobody enter, and then you're having some problem there. Yeah, but I mean, to develop something extra on top of what we have, I wouldn't worry. I wouldn't go to see the package application. I just would go and develop it in this way. And the guy who is yes, and the guy who is packaging the stuff over time, he figured out is if everything is something is not working, and he fix it, and it maintain it like working. Okay, but for yeah, but for developing new stuff, you don't really need it. I haven't even looked at it yet. I just ran it once, but to see how it looked like, but that's all. Okay. Okay, so let's continue to the any other question you want me at this stage? Okay, so another very important part. Okay, I showed you how to open it with the IDE and how to debug the platform. Okay, that's important. The next important thing to understand is the way the rest of the code is organized. That is inside this projects folder. Okay, so we divided the whole SuperAlgos project into code projects. Let's call it that way. So each code project has a folder here, and inside it has some structure that is more or less the same in all of them. Like it might have icons, plugins, something we call schemas. This TS is referring task server or user interface. And if you see them one by one, you will find more or less the same structure. Okay, so the whole code base, let's say, is divided in code projects, and you can think of them as libraries, but specifically for SuperAlgos, okay, because they are organized in a certain way. So here you have assets that can be icons or can be JSON files with kind of configuration that we call schemas, and also can be code, JavaScript code. So this structure here on the IDE looks like this. Okay. Okay. So this everything in here can be used by any of the applications of SuperAlgo. That today the biggest application is the Algo Traders platform, but the network that we are building since 2-3 months is a second application, and the desktop is another application, and maybe there are more emerged over time. Okay, so this is an open multi-dimensional projects, so more applications are expected to emerge. And we have a good library of assets here, including code, that can be reused across all these applications at the same time. Okay, that's the idea and the way it's organized. So the next most important thing to understand is, beyond that we have the code-based device in code project, is that there is one file, that is this project schema file, that ties everything together. It's a file that has the definitions of all the code assets. We are not talking here about the icons or the other schema files or plugins or whatever, but all the code assets are defined here. So it's a definition file where you have project by project, algorithmic trading, portfolio management, machine learning, visual scripting, foundations, and whatever. The whole list of projects have their definition here. So let's explore that. And this is very important because it's central. Every time you add a new module to these libraries of modules, first you have to declare the module here in one of the different categories that we find out that were useful, like global function libraries, utilities, spaces, or whatever. You have to declare the module here at some point here. Oh my god, I forgot to switch to the code view. I was not showing this to people. It's going to be a boring video. Okay. Yeah. And we are 15 minutes into the video. Okay. Sorry for that. But anyway, the explanation is still in voice. Okay, so what I was saying is that this is a very important concept. We have all these libraries in here, dividing the code base in code projects, and we have one single file where we have to declare each of these modules. Okay, I would like to go a little bit deeper because this is really the backbone of the whole system. This set of libraries. There's a lot of work that has been put in all these libraries that allows you to manage all these node structures in different ways. You have everything in here, and the goal is to have it as organized as possible and as reusable as possible. And we have code both for running at the browser and running at Node.js. Okay, so how do we organize this? That's the question. So let me open one of these guys as an example. Let me pick one. For example, governance. That is something that you would like to work on. So I'm going to explain you in the same context because you might be needing to add some module here or modify or whatever. If you're going to modify the code, there's nothing to touch here because the module already exists. The thing is, if you are going to add a new module, then you have to add it here. Or if you're going to move this a module from one place to the other, then you have to move it, both the physical file at the disk and also the configuration here. Okay? Make sense? Okay, yeah, I can differentiate later what is a plugin. Remind me if I forget. But yeah. Okay. But essentially what we call a plugin, I will open one of these here, for example. I will do it with governance as an example. So we have icons. Everybody understand what an icon is. The sources of the icons, the PNGs. These are not icons, but maybe they are PNGs for tutorials or documentation, something that are needed somewhere. What we call plugins are essentially, they are expressed in JSON files. Okay, with they are usually a structure of nodes that you can create at the user interface. For example, in the case of the governance system, each user profile is also a plugin. Why? Because when we save this, it is saved on a file here on the governance project, plugins specifically under user profile. So here you will see that my user profile is this one, okay? So it's a JSON file with information. There's no code. Usually there is no code. There might be code if the plugin is, for example, a trading system, and you have a condition, and then you put inside the condition some code, okay? But it's code that is a property of an object. But in essence, it's a structure of these objects that you can create here at the user interface. So for example, user profiler plugins, where I'm not at the governance system, but I can go there. For example, let's go here. There are not so many people. So in other words, a plugin to the system is something that is not part of the code base, but is data information that is needed, and each project might have their own plugins and define their own type of plugins. For example, user profiles are a type of plugin of the governance system, and trading systems are a type of plugins of the algorithmic trading project. Okay, so more or less, make sense? Yeah. Okay. Okay. Just to say it in another words, plugins are plugins are not part of the code base, but are created by users. Okay. So user create plugin, and they are included in the repository, but it's a layer on top of the code base, because the code base is modified by developers, and plugins is what users want to share with the rest of the community. Okay, they create plugins as indicators, plotters, trading systems, user profiles, or whatever. Yes, yes, it's like a data store layer, but also created by users. Okay, is what users contribute to the systems. I mean, developer contribute code at the code base layer. Okay, users contribute plugins. Okay, see if that makes sense. If that makes sense. Okay. Okay. So a quick explanation on schemas, and then I return to the to the project schema. Schemas in general, if you see here, well, we have plugins and we have schemas. There are two categories of schemas. One that is app or application schema, and the other related to documentation. Okay, documentation is in general a schema would represent a page at the docs. Okay, a page of some kind, but it's also a JSON file. And in the case of the application, it represents an app schema is each node definition. For example, let's go to the most basic here, that is the user profile. User profile here. So if you see the user profile schema, it's this file. It's not so big. Essentially, what do you have? You have the definition of the menu items that the user profile node is going to have. Okay. If you come here and you see my profile, you will see that this have configure, add child, install as plugin, save plugin, and delete. And you can see here configure, add child. These are submenu. install a plugin, save plugin, and delete. Okay, so each of these uh, paragraphs here is one of the menu items here at the node, right? Okay. Uh, and probably there is, because the docs is quite complete. If you go to, I cannot, I'm not in charge of that, so I don't really have in my mind everything that has been documented, but it's quite extensive, to be honest. So, for example, every node has its own document page, user profile. What I don't know if there is a, well, probably I load a workspace configure not to index the documentation. I don't recall that there is a glossary, but most of the concepts are documented. So probably not. Probably not, because the part of the developer side is more difficult to document than the usage of the system. Um, and well, and still the system is been evolving a lot and quite fast, so it easily gets outdated. Okay, I'm going to reload this workspace with the indexing of the docs in true, so that I can check it out. But let's continue here with the app application, the explanation of the app schema. You have, for instance, the definition of the menus of a node. If the node is going to be able to access the editor for the configuration. Another important part is the declaration of which type of children a node can have. Okay, this is the list of different type of children that the user profile node can have. So when I add a child, I can add of all these types declared here. Okay, um, and well, and then some other not critical important stuff, like for example, if the title of the node is going to be visible or not. One that is important is the concept that we have here, that there are two relationships between the node, like parent and child. This is the child of this parent, okay? And the relationship of references. So a node, for example, um, this node is referencing some other node. You see that a different line there, like a white line with some dots. Okay, that's a reference type of relationship. So we managed to beat everything with these two type of relationship. Or you can be a child of some other node, so that means that you have a parent. Or you can reference other node, and the guy who you are referencing, we call it the reference parent. Okay. Uh, with pretty much two type of relationship, you can do a lot of stuff. That, by the way, is more or less what happens at the code level, no? At the code level, you also have references and things like this. So here, if you see the app schema, a very important part is the declaration of this node, which are, well, in this case, it cannot have a parent because it's the head of a hierarchy. But if you open any other one, you will see that attaching rules means which are the nodes that can be its parent, like that this node can attach to. And there is another very similar property that is referencing rules, that you can set up a list of all the nodes that this node can reference. Okay, referencing rules. Okay. In this case, it's only one type of node, but it could be a list of many. Okay. So essentially, to not go too deep on this, what I want to say is that the APP schema is an important concept here because it's the definition of each node type. Okay. And because it's just a file with a configuration, that means that if you want to add more node types, the only thing you need to do is to create a new file there. And pretty much that's it. You're going to define which are the menus it can have, which node it can attach to, which node it can reference. If you create that file plus an icon with the same name of the node, then it will match and together, and you can easily create an application. Okay, just by configuring this stuff. Yeah. Another way to see this is here. For example, if you put task, now I should have task is a node. Okay, we have the documentation of each of the nodes, but also we have a documentation that is auto-generated based on the APP schema of the task node. So these have these menus. Okay, with the properties that the app schema. This has these children, or these possible children, and attaching rule can attach to the task manager. Okay, and everything is linked, so you can navigate also that information. I hope in some days somebody is going to allow us to create this app schema file directly from here, or from an interface similar to here, so that we don't have to deal with that manually. Because even if it is very efficient just creating a file and you have different node types, still is a lot of work if you have to create a lot of stuff and match children with parents and with who can reference directly from the file. No, so there is a project for this. I don't remember which name we put to it, but some new developer watching this video might want to take it and do it, so we can go even faster. Okay, so that's the concept of the APP schema. Cool. So between all the stuff we have here, to recap, we have these app schema files, which are an important part of the system. These are similar stuff, but relating to documentation. We don't need to get into there. We have icons, and we have plugins that depends on the project. If you see the plugins of Foundation, they are API maps, tutorials, and workspaces. But here in government, you have asset, feature, pools, position, user profile, and workspace. So this depends on, these are user create assets. And there is no more than that. So the system is big, but it's constrained to this structure. Okay, it has many projects, but the concepts are the same. Every project has app schemas, every project have icons, and every project have documentation, and pretty much that's it. Okay, and JavaScript code, and that's it. Okay, so let's go back. Any question there? Okay, let's go back to the governance, to the project schema. Okay, because there is some explanation that you need to know here in order to understand how this is organized. Okay, here we are trying to classify the JavaScript modules like in 2 dimensions at the same time. Okay, there are 2 dimensions. One dimension is to which project it belongs, and the other one is at which application it will be needed. Okay, so let me explain that in more detail. You see this initial here, UI, task server, this is platform, PL, okay? So this dimension of classification tell us where the module needs to be loaded, okay? Because there is a loading mechanism that is going to load the module so that you have it ready to use, okay? We have that implemented already. So if a module is going to be used only at the platform, then you add it here under this PL stuff, okay? As you can see in governance, there are none here, it's empty. And in governance, there is nothing running at the task server, okay? In governance, almost everything runs at the UI because everything is about connecting your boats and blah, blah, blah. So you will see most of the governance modules under UI, okay? And just by putting the module here, then it's going to become available at the browser and you can use it. If you debug here, if you go to the browser sources, then you will see that there is a folder projects, and there is a folder governance, and there is a folder function library, global spaces, and utilities. That is exactly the same that you have here. Global function libraries. Well, this is large. Library utilities and spaces, okay? Exactly the same stuff. You find it here. And inside utilities, you have bonus program, common table, blah, 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 all this module. That is exactly what you have here. Pools, tables, descended. Okay, not in the same order, but you have all these modules. So that means that if you need a new module, for example, for governance, what do you do? If it is going to be at the UI, you add it here. Most of the time, I just copy one of the existing and then paste it, change the name, change the function name that has this naming convention with project name plus utility because it's an utility and the name conversions. So you add your own definition of what you need. Then you go and create a physical JavaScript file that usually I copy one of the neighboring ones and rename it and empty the, the entry functions. And you write the code and it magically is going to appear here available at your browser to be used within the browser with the rest of the application. So the only thing you have to do is that you add it here. No, you have to reload the page. The server, no. Reload the page. And you will have it here. And if it is a change on an existing file, you just modify it. No need to change or touch the project schema. Reload the page, and you will have the change here. And you can debug it immediately. Okay? So there is a few details here. There is a special key that is SA that is not here and governance because it's not needed, but I will find it in another project. Data mining, probably not. Okay. Algorithm trading. I'm looking for foundations. Okay, foundations. Foundations have UI, have TS, have PL, have almost everything, and SA. Okay, what does SA mean? This module, web access, is going to be loaded at the platform. Okay, is part of the foundations project, this chunk of the code base, and it's going to, because it's inside this, okay? The modules that are defined inside SA are going to be loaded regardless of the application you are running. So this is going to be loaded, for example, time constants or schemas or miscellaneous function or whatever here are going to be loaded at the platform and also at the network and also at the desktop app and also at the web app of the platform. So if you have, for example, constants or things like this that you need it everywhere, but you don't want the code to be duplicated, then you put it inside this area, SA, and they're going to be available at every place. That's all you need to know. When it is not SA, it's going to be loaded specifically at the application where it is declared. When it is in SA, it's going to be loaded everywhere. It's going to be available everywhere, and you just use it, okay? And use it, and just like that. And that's the project schema file. There are no more secrets or nothing else to know regarding that. Any question? Exactly. Yeah. Yeah. Yes. And you have to place the code, obviously, in the folder structure the same that you are declaring the stuff. If you put it somewhere else, then it's going to fail this automatic loading, and you're going to get stuck somewhere over there. Yes, that's the reason why I'm recording this video since a week or 10 days. Uh, because I hope the people that are working now on documentation that are getting more and more independent. Now, instead of me explaining them, they can watch the videos and from there extract all the information. So yeah, that scales better than me explaining every time, all the time. Okay, so this is pretty much the overview. There is another interesting thing that you should know, that is, but probably you will not need it because you are going to be working on governance as far as I can see. But it's interesting to know the execution time. What is the relationship between this application and execution time? Okay, for example, what I want to say, when we have the platform that I told you that is a Node.js process plus a web application running at the browser. Okay, so these two things are connected between each other. Okay, the connection between each other is via two mechanisms. One is HTTP and the other is WebSockets. Okay, so that means that the platform client, that's how we call the one that is running at Node.js, have an HTTP interface and a WebSocket interface. And the web app is talking to the client via this mechanism. Okay, for fetching files and data, use the HTTP. For real-time communication of what is going on, or what, I don't know, a bug testing session is running and the information needs to be flowing into the user interface and changing the number there, that's go via WebSocket. Okay, so that this is important to know. Okay, how this is connected in at execution time. Then you have the task server. The task server is a process that represents a task. I'm going to illustrate this by loading. I'm going to load the, well, I can load what I was working, trading signals. Um, when you run a bot for trading or for data mining or for machine learning or for whatever, we don't run it at the client, at the platform client, because that process is not for that, okay? So we run it at an external process, external Node.js process. And this external Node.js process is launched from the platform client, okay? So it's like a forked process, but it's an independent process, okay? It's an independent Node.js process. You go to the task manager, you see the process there. Okay, so that means that for every task we run, a new Node.js process is created, okay? So for example, if I come here and I run, let's say I want to update my data, and I come here, wow, there are a lot of stuff here. Well, I'm going to do it only with this to illustrate the case. So this is the process, for example, that extract data from an exchange, extract raw data, okay? We call it a sensor bot because we define it that way. And this is a data mining process that the candles that we extract, 1 minute candle, they process this into candles of every time frame, okay? So if I come here and I run this all tasks, what is going on is that I'm sending a message via WebSocket to the client of the platform that is going to create these Node.js processes, okay? And it's going to feed them with the information they need to run this bot. And once the bot is running, it's going to do whatever is programmed to do. Then in this case, to download data from an exchange. And once this finishes, this process is going to automatically run and do whatever is programmed to do. Okay, so I'm going to turn this off because I'm seeing that it's downloading the whole history again, and I don't really want this to happen because I already had this data in my computer. I don't want to reprocess everything. But essentially, what I want to illustrate is that the you have these entities now. You have the web application running at the browser. You have the entity of the platform client that is a single Node.js process. And then you have any number of task process that is the task server application. Okay. And this task server application also connects to the platform clients via WebSockets in that case. Okay. So everything is connected uh, with all the other stuff. And that's clarifies a little bit how this is at runtime. Okay, make sense? Okay, so this is on the context of the platform. If you want, we can move to the network, the desktop app, and continue the explanation there. But I'm not sure you want to get there now. Mhm. Yes, this the Super Argos network. Yes, the Super Argos network. Yeah. Hmm. Okay. If you want, yeah, yeah. Okay, so developers, we are working at the develop branch. Um, so once you clone the repository, you switch to the develop branch. You can do it with git command, and we also create here a feature to switch branches from for people not so technical. So from here you can switch. I'm currently at the develop branch, but I could switch to master, for example. And we have this concept of the contribution branch. That is, if I make a push, where is it going to go? Okay. So is it going to go to develop or master, even if I am a developer master? So we usually are in develop and contribute to develop. That's the setup. And once you put this here, then usually as developer we don't move from there. It's one time stuff. Then we yeah, that's up to each one how you are used to work. You can freely do whatever you want. Uh, Yeah, because this interface is for people who are contributing, but they are not developer mostly. For example, the people doing tutorials or writing documentation. Then what you do is you explain to them that here they set up themselves in develop, and from there they start adding more documentation or updating whatever, and everything is going to work. They don't have to worry. As developer, if you are working in more stuff and we want more branches, then it's our problem. We forget about this and we do it with git, and that's it. Okay, so this is no, as developer you're free to do whatever you want. This part is mostly for the people contributing plugins of any kind. I- yes, because if they stick to this, they don't need to learn anything about git if they stick to a certain workflow. Okay, and also, but I do use these commands to update and app contribute. Okay, uh, because there is a certain circuit. um, the way that we have um, this structure, remember that is mostly the structure is also to simplify the life of people not so technical, but we have the upstream, that is the SuperAlgos repository at the SuperAlgos account, right? That's the upstream. Then we have our each one have their own fork. Then and the fork is living at GitHub. Then we have our local, that is a clone of the fork, right? So the workflow of information comes from the upstream, comes to our local. This app update, what we are doing is we are fetching the upstream into the local, okay? Not going through the fork. So when we do a app contribute, what we are doing is a push from the local to the fork and a pull request from the fork to the upstream. Okay, so it's like a circle. It's like a circle. From upstream comes to the local, from the local with the contribute goes to the fork, and a pull request is created so that is pulled from the fork to the upstream. Make sense? Exactly. If you see the code of this, how this is resolved, is two or three git commands that do these tricks under the hood. Okay. And usually that works also for developers unless you are dealing with multiple branches, then you will have to figure it out using Git yourself. But if you are doing like things and committing on your changes every day or every 2 days or every 3 days, most of the time just doing app update and app contribute solve all your problem, and it's very quickly. You don't have to think about anything. And yeah. just works. That's the workflow. Yes, we have the issues at GitHub, but also the the project code base is divided in project, and we are supposed to have a maintainer for each project. But reality is that most of the project, the maintainer is myself, except for a few that already some people have took them. And what does that mean? That we are not we are not that well organized yet there, because uh, each the idea is that each of these projects get to have a maintainer that is going to be resolving the issues of each of these individual projects, and pushing each project further, like iterating over the project, so improving it over time individually as, as a code project. So that means that the issues themselves, what is happening as of today in real life, is that some people are uh, defining the issues, some people are checking the issues, and there are some developer working on them, but they are not really the maintainers of any project. So it's like newcomers developers take the issues as a way to start getting familiar with the software, and they start solving some problems. When there are some issues that are more urgent, yes, urgent, then some developers that are much more familiar with the project, they take them so as they are resolved faster. But there is no like a very consistent way of dealing with the issue so far, because still the manpower is limited. Okay, so that's where we are now. That there are more developers in this year, the last year, uh, notably much more than before. Now I'm trying to dedicate myself only on the development of new stuff that is missing. So I'm pushing the frontier, like I'm on the front line, and leaving the issues and all the others maintenance to all the other people that are coming and are training themselves into the code base and things like this. So I'm since some time now, I'm not solving issues myself. Yeah. Yes. 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 Yeah. There is one of the project that is more advanced on this in this sense is the education project, and the guys there, they have I don't know exactly where to find it, but I think it's here, projects documentation. But in the end, I think they are tracking issues when they put it in a different format to get organized better. Let me find it here. Oh, I don't see the education project here. Uh, maybe, or maybe it's not at the account level, but it's at the repository level. Let me check this. Projects. No, well, I don't know where they have it, but or I don't know what happened with there was an education project, and they have like a dashboard with a lot of all the issues related to that project and which was the status of everything. And but in the end, I think that everything was in issues anyway. So I think that issues is the place that you are looking for. Yeah. Well, everything that is inside is in the form of documentation, in-app documentation. So depending on if it is going to be discussed and you need people to comment and to reply and blah blah blah, that would be an issue. If it is a documentation of something how it's going to work, then everything is documented here. And there is a way to add documentation. There are commands for that, docs, add or something like this, or a docs. So you can add a new type of document, docs add command. You can create, yeah. There is no mechanism so far because so far we didn't work with the concept of proposal. I understand that this would be probably the first case needed because we would be discussing policies regarding the where the tokens are going to be issued or whatever. That makes sense. But before that, there or either when policy was decided, there were probably few people to decide it with, so there was no need to have an automated mechanism, or we didn't even have a governance system. The governance system that you see today is 3 4 months old. So everything before that is there was no automated or in system way to vote or to decide. Just we discuss it in Telegram groups, and that's it. And let's do this, and we do it. Now we have a go. Yeah, I think that still at least at this stage, I wouldn't go to create a functionality to vote on this stuff. I probably try to get an agreement or a consensus of how you were discussing this at the chat group, and probably create a, I don't know, a document, a blog post or whatever. And if most of the people agree that that's the best thing that we can do now, we just go and do it. In general, if it is just software and not policy, then the rule here in the project is that if you are going to invest time in doing something, then you decide how it's going to be. So if I'm investing my time in doing the network, then I don't need to ask anybody. I just do it however I want because I invested my time on that. Somebody later want to improve it, yes, they are free to improve it. And if we don't agree, well, maybe we end up with two networks, So that's more or less the policy. We are giving a lot of priority to whoever is taking their time and energy to put it into code. So if you're going to do something in the system, for example, the smart contract in Ethereum and the upgrades of the governance system to do, you are the one to decide because it's your time that you're investing. Okay. Now, even other, because they have tokens, there is not that powerful enough to influence. I mean, they can influence you. You should try to get consensus, but the final decision is yours. This is more or less the philosophy here. Uh, for most of software related stuff, if we are talking about like policy economics, yes, obviously, uh, if I would do it, I would I would search for the consensus of almost everyone, and because this is like different just code. If I want to a new menu system, I can do it however I want. I don't ask anybody, absolutely nobody. But if I were going to change, not to change the policy, but yes, somehow we are defining how exactly where exactly we are going to issue the token. Yeah, yes, let's agree on that. And if everybody is agreeing, and then the details are up to you. Okay, exactly which is the smart contract. You don't have to convince anybody. You just go and do it, or make the pull request. People are going to review it, but you are supposed to have in the last word there. That's more or less the philosophy here. Yes, because still we have the plane already at the airport with the nose up. We have to still make the plane fly, so we cannot be wasting energy in things that are not really critical. So if there is energy to be used, let's use it in the most efficient way, that is building something. And that's it. Amazing. This is a record time, 1 hour. And on top of that, we will use the video for everybody else. Yeah. Then you have, I know there's a lot of hours, but if you get bored someday and you want to watch some of the videos I'm recording, you might be able to extract also useful information from that. It's not that I'm recommending you to spend 20, or I don't know how many hours I already record in a week, but there is some useful information for any developer that would like to go deeper into this. At least they can see firsthand how I organize myself, how I work in real life, and from there you might extract something that is useful. Yeah, exactly. Perfect. So I think you're ready to go. Maybe if you want, we can do a follow up someday once you accumulate more stuff, or maybe you don't accumulate anything at all to ask. But we can. I'm open for extending this session into more videos if needed, so that we can go deeper. Excellent. Okay, so let me stop this video. Thank you everybody who's watching. Wish you good luck. 1 second.